Hi, this is Jenny, and this is my video report for experiment 2. So introduction. The purpose of the experiment is to measure the distance dependency of the magnetic field due to our magnet, and also we compare our measurement with computational model. So we have some main results of the experiment. We can conclude that as the magnetometer moves closer to the magnet, the measured X component of the magnetic field increases. And also we get some specific value for our magnetic dipole moments and measured and calculated B naught, which are listed above. And in this experiment, we need to measure off-axis magnetic field by using a magnetic bar, a magnetometer sensor in our phone, and a ruler or a meter stick. We made an assumption before the experiment, which is the on-axis field of the magnet and the Earth's magnetic field should be orthogonal to each other. This should be accomplished by properly set up the direction of our phone and the magnet. So in this experiment, the system is the magnetometer sensor, while the surrounding is the magnet and the Earth. So the main physics idea is that we assume the magnitude of the magnetic field due to the bar magnet is proportional to some constant times some power of the distance. We calculate magnetic moment and use that we can calculate off-axis magnetic field. So there are three equations that we are going to use in this experiment. So the first one is the equation for distance dependency, and also we have the formula for on-axis magnetic field, and at last we have the general formula for magnetic field. So we use the first two equations to calculate the value of mu, which is magnetic moment, and then we plug the value of mu into our general formula. So in the first part of the experiment, we should first locate the magnetometer sensor by moving our phone around, and then we can make some observations of on-axis B field. So we record all those data into the spreadsheet, and then we got this plot, ln bx versus ln r. So we can get the value of k and n from the plot. So the observation conclusion we made here is that as the magnetometer moves closer to the magnet, the measured X component of the magnetic field increases. So with the value in the plot in the previous slide, we can calculate the value of mu, which is 4.98 ampere times meter square in this case. So for the second part of the experiment, we need to calculate off-axis B field. So we first find d perp, which is the distance from the magnet to the phone when on-axis bx naught equals to 100 mu t. And then we put our phone at a location which is d perp to the magnet in both x and y direction. So then we can get the measured value of bx, by, and bz from our phone. And with those values, we can calculate b naught, which equals to 1.116 times 10 to the minus 4 Tesla. And then we use a computational model to simulate the experiment we did before. So the first part of the coding is the simulation of observations on axis and on perp axis. Those are represented by blue and orange arrows. And the second part of the coding is the simulation of the off-axis magnetic field, and it is represented by the purple arrow. So the value calculated by the computational model of off-axis magnetic field is 6.79 times 10 to the minus 5th, and we can see that it's quite different from our measured value, so there must be some possible sources of error. So there might be bias when I'm measuring the distance or I'm reading the value from the magnetometers. Meanwhile, there might be other sources of magnetic field that influence the measurement, like my iPad or my computer. And besides from that, the data on my phone might not be 100% accurate. So they all may lead to error. And what if and why? So what if I didn't orient my setup so it compensates for my magnetic noise? So in this case, the on-axis magnetic field from the magnet won't be orthogonal to the magnetic field from the Earth. So the process of separating measured magnetic field will be way more complicated. And what if I have two identical magnets stuck together end to end? So I believe in this case the magnetic field will be much stronger than the one we get in the experiment.